Okay, so we're going to do the distance method here, finding the distance between 2 points. And you, so let me give this diagram here. The distance formula is really just the Pythagorean theorem. You get this horizontal distance between the two scores, or between the 2 points. It's called A here. And you get this vertical distance, which would be like y minus y0 in this diagram. And then you square the distances, add them together, and then that's the square of the hypotenuse, or the square of the distance, and you take the square root of that. And then that's essentially that's the distance formula. And it even started here. I'll grab that. Inside this class, this point class, I have this public float distance. Okay, so if you understand that one of the points is calling the distance method, and that's the method, that's this, the thing calling the method. The other point has to get passed as a parameter, so it's called other here. So when I talk about this x, that's the x coordinate of the point calling the method. When I talk about other.x, that's the x coordinate of the point that gets passed as a parameter. Okay, and then, so once I have these, and we don't have to break this down into so many steps, but just to kind of separate it some, I'll call it x diff is this dot, or let's call it first x, since I made those variables, minus second x. Y diff, the difference in the y coordinates, is first y minus second y. And it doesn't matter which order we subtract those in, as far as whether it's first x minus second x, or if it's second x minus first x, because we're going to square those values. This is like a and b here, essentially, right, in that right triangle. So I'm going to square them. And, an easy way to square x diff is to multiply by x diff, right? There is something in processing called PAL, I think. Yep. And that would be y diff 2. So it's like raise y diff to the second power. So I'm doing it two different ways. Multiplying it by itself, using this power method and returning it, and raising it to the second power. So I'm returning that. So that's the distance formula. And then if we tried that, let's see, it's probably going to tell me, like that. And the one I'm going to look at is, the distance between P and Q. So these are the points. P is 3, 5. That's this point. And Q is 6, 1. That's this point. And we get a distance of 5. And I know that because this is a 3, 4, 5 right triangle, right? The horizontal distance is 3 units. The vertical distance is 4 units. So 3 squared plus 4 squared is 25, and then the square root of 25 is 5. So this distance, if we put it on a straight line, would be 5. Okay? So that's the distance method, and showing that it works,